Chapter 3, Section 3 is zeros of polynomial functions. The first question says to use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. What you're going to do is set up this problem using synthetic division as if you were taking the first polynomial x cubed plus 9x squared plus 14x minus 24 and dividing it using the synthetic division, dividing it by x plus 6. If the remainder is 0, then we can say yes, this x plus 6 is a factor of the first. So with our setup for synthetic division, we're dividing by x plus 6. So we're going to put a negative 6 in the box, and then we're going to use the coefficients of the polynomial, 1, 9, 14, and negative 24. Always bring down that leading coefficient, and whatever's below the line you're going to multiply by what's in the box. 1 times negative 6 is negative 6. 9 plus negative 6 is 3. 3 times a negative 6 is negative 18. Positive 14 and negative 18 give you negative 4. Negative 4 times a negative 6 is a positive 24. A negative 24 and a positive 24 is 0. Since the remainder is 0, so we can say that x plus 6 is a factor of this polynomial. So let's check our answer. All right, let's look at number 2. Again, use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. The setup for synthetic division, we are dividing by x plus 3, so we're going to put a negative 3 in the box and listing the coefficients, starting with 5, 12, negative 6, 12, and 9. Bring down the first term, first coefficient, 5, multiply by the number in the box, negative 15. 12 plus a negative 15 or 12 minus 15, either one give you negative 3. Negative 3 times negative 3 is a positive 9. Negative 6 and a positive 9 is positive 3. 3 times negative 3 is negative 9. 12 minus 9 is 3. 3 times negative 3 is negative 9. And then 9 and negative 9 is 0. So we do get 0 is the remainder. So that means x plus 3 is a factor. So the answer is yes. Okay, let's look at number 3. Use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. Well, we are missing an exponent here, so I'm going to write this as negative x cubed plus 0x squared. There's a missing x squared term, so you want to put a 0 in the setup for synthetic division. Okay, and the other polynomial is x plus 3. You want to divide it by x plus 3, so that means you would have a negative 3 in the box. Then using the coefficients, beginning with negative 1, 0, 6, and negative 9, bring down the first term, first coefficient of negative 1, multiply by negative 3 to get positive 3, add 0 and 3, multiply 3 and negative 3 to get negative 9, 6 and negative 9 give you negative 3. Negative 3 times negative 3 is positive 9, and negative 9 and positive 9 is 0. The remainder is 0, so we can say x plus 3 is a factor. Let's continue. Number 4, use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. I want to rewrite this one because there is a missing power of x. We have x to the third plus 8x squared. We're missing the x to the first power. So I'm going to write a 0x and then a minus 9. We want to determine if x minus 1 is a factor. We're going to set up the synthetic division with a positive 1 in the box because we're trying to divide by x minus 1, and then using the coefficients 1, 8, 0, and negative 9. Bring down the first coefficient 1, multiply by what's in the box. 1 times 1, 8 times 1 is, 8 plus 1 is 9, 9 times 1 is 9, 0 plus 9 is 9, 9 times 1 is 9. Alright, the remainder is 0, so we can say x minus 1 is a factor. Okay, let's look at number 5. Use the factor theorem and synthetic division to decide whether the second polynomial is a factor of the first. It looks like we have all of the exponents, so we don't have to rewrite it. We want to know if x plus 4 is a factor. We're going to put a negative 4 in the box and use the coefficients 4, 4, negative 14, 140, and a positive 5. Bring down the first coefficient, multiply 4 times negative 4 to get negative 16. 4 minus 16 is negative 12. Negative 12 times 4 is 48. Sorry, negative 12 times negative 4 is 48. Negative 14 plus 48 is 34. 34 times negative 4 is negative 136. 140 minus 136 is 4. And 4 times negative 4 is negative 16. 5 and negative 16 is negative 11. Alright, so for this one, the remainder does not equal 0. Since the remainder does not equal 0, we can say x plus 4 is not a factor of that big polynomial. If we ended up with a remainder of 0, then we could say yes. The remainder is negative 11, so x plus 4 is not a factor. Okay, let's look at number 6. We want to factor f of x, which is equal to 3x cubed minus 11x squared minus 24x plus 20 into linear factors. We're given that 5 is a 0 of the polynomial function. Alright, let's go over this type of problem here. We're going to do synthetic division with a 5. Now, if 5 is a 0, this means that x minus 5 is a factor. That is key. That's a very, very important property of the synthetic division. If you know 0, that corresponds with a factor. So we're going to use synthetic division with a 5 in the box using a 5 in the box and the coefficients of the polynomial 3, negative 11, negative 24, and positive 20. Bring down the first coefficient, which is 3. 3 times 5 is 15. Negative 11 and 15 is positive 4. 4 times 5 is 20. Negative 24 and 20 is negative 4. And negative 4 times 5 is negative 20. And we have a remainder of 0. The remainder of 0 says that 5 is a 0, and what that does is it corresponds to the factor of x minus 5. This polynomial can be factored into one of the factors. Alright, so this polynomial function can be written as 3x cubed minus 11x squared minus 24. This is the same thing as 5, which is a 0, corresponds to a factor of x minus 5. And this part right here is going to be used to find the other factors. So this was an x to the third, and you divide out by an x, so we have 3x to the second power plus 4x minus 4. So our polynomial function can be factored. The factors of 3x cubed, sorry, okay, the original function, the polynomial function, was 3x cubed minus 11x squared minus 24x plus 20. So 5 is a 0, so that means x minus 5 is a factor. The other factor is what you find below the line in synthetic division. So that is 3x squared plus 4x minus 4. Now, this trinomial can be factored even further. You can use the AC method or the guess and check method to find those factors. 3x squared minus 4. Since the first term here is 3x squared, I know I'm going to need a 3x here and an x here. And the factors of the negative 4, that when you multiply doing the outer and inner, that's going to give you a positive 4, is going to be a plus 2 and a minus 2 in that order, where x minus 5 is a factor, 3x minus 2 is a factor. Alright, so for this type of problem, you're given 1, 0. You're going to use that to find one factor, and then synthetic division is going to help you find the other factors. Now, the way I got this was using the guess and check method, but you could also use the AC method that we covered in the review chapter for factoring polynomials. This gives us an alternate way, but using synthetic division, we get x minus 5 as a factor because 5 is a 0. And then the other factors are 3x minus 2 and x plus 2.